Hey, I'm Serge, and I'm the head of Databricks Labs, and I'm going to be talking today about building Databricks integrations with Golang, because basically you can use Golang for anything, like from infrastructure to the applied LLM use. So I'm in Databricks since 2019. I'm the author of the Databricks Terraform provider, written in Go. I'm the author of Databricks SDK for Go and for Python and for Java. And I initiated the replatforming of Databricks CLI into Go from Python, because Python is not the right language for building scalable applications. And now I'm driving Databricks Labs full-time, and I have love-hate attitudes towards Golang since 2020. So we're going to be talking about two use cases today. The first one is release notes with LLMs using Go, and then the other is cleanup of Databricks workspaces, because essentially we have to do that to keep them secure. So briefly about Databricks Labs, we have roughly 50 repositories in the public GitHub organization. They're all source available or open source, and we have to release them. And we release each one of them roughly every week, and we have 50 things to release every week. And essentially, it's a full-time job for a full-time employee. And big part of releasing is actually writing the release notes, because if you don't write release notes for your application, you don't know what's coming in as the incremental functionality, and you don't update your libraries or products or toolings. And by having very good and extensive release notes available to you while you update, you know what exactly are you expecting to see in the given release. And as you know, like writing proper release notes for each release is something that can take you like roughly 1 hour if you release like 20 different things within one app. And yeah, I decided to automate it because I was bored of doing that. So it was actually quite simple. So for every git commit, we are taking the git commit diff, what you see on the right hand of the screen, and feeding that into the LLM. And then we did it for every file and for every commit. So that each release, we get a summary for every commit as one line, as a human-readable paragraph of text, and fed that into the pipeline. So roughly, the pipeline was looking... one second. Roughly, the pipeline was looking the following way. We get unreleased commits, then we get diff per that commit, we split the diff per file. Essentially, LLMs have short context, so it's easier to fit the context of a difference of a same file. And we summarize the change for the file. And after that, we summarize all of the changes of those files. And then we write the changelog.md file for every release. And then we write the announcement for this given release into public channels like Medium posts, Twitter, and LinkedIn, and other things. So that we have a bit more self-driven marketing, because we don't have full-time marketing people working on this thing. So, here is what we have as part of our automation stack in Go. Here's our LLM prompt. Here is the commit message terminated by triple dash for the context. Do not hallucinate. You're a staff software engineer and you're reviewing one file at a time and with unified diff format, blah, 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 blah. And then, given this prompt, we get it to analyze the get repository commit. We call GitHub public API to get a diff of public API of this commit. And then we feed it into the LLM as the chatbot. So probably here on the screen you don't see this, but we have a conversation with the LLM happening, and it's purely implemented in Golang. So this thing is written purely with using of Databricks SDK for Go. I authored like 2 years ago, and it does not need any other external dependencies than parsing of Git unified diff. And it took like roughly 2 weeks to implement, and it saves a lot of time. What was also saving a lot of time to develop this was the Databricks model playground. This is an awesome feature that allows you to fine-tune prompts and verify if those prompts that you are working on produce the expected results for your inputs. Because essentially, while you're writing the practical LM application, you need to pick the right prompts, and you need to compare the results of different prompts. And LM Playground of Databricks allows you to select a different model if it performs worse or better, and compare them side by side, almost like a integrated development environment. And I discovered this relatively later in the process, but it allowed me to fine-tune and get better and more understandable results from the applied AI application. So let's actually take a look at how the actual LLM call is happening. So we have a function that performs talking with the LLM. And as the input, we give it message history of all AI and human messages happening between LLM and the user. And we call the serving endpoints API. Using serving endpoints API, we provide three things: the model name, the messages from the history, and number of max tokens that we can configure on every command line invocation. And then once we receive the result from the serving endpoints API that we usually get within 30 seconds for the Mixtral model, we get the choices in the response, and we output the assistant messages. That's it. Like, I am doing this talk with the single purpose. Using Go is so simple because it does not require any prepackaged, any third-party dependencies to be installed on the system. And you can build an app that is cross-compiled and prepackaged with all of the dependencies necessary available to your end users. And it's so simple with Databricks SDK for Go that you don't really need anything like LangChain if you need to do a simple interaction with the LLM. And you can just call the APIs of Databricks, and Databricks APIs is so feature-rich that they can provide these things for you already out of the box without you having to bring 1 gigabyte of dependencies while you are actually building LangChain and care about incompatibilities and other shenanigans that you have in those situations. So Go is a very simple language that allows you to grow your applications over the course of time. Now, so it's very simple as to write, and it's actually very simple to use. So here is the screenshots of usage of this as a command line tool. In production, we integrate it into our release tooling that is a bit more involved and creates all of the releases and packages and runs the test. But here, I've created a small version of this tool called LNOs that is available for you to download. That's, for example, can summarize a pull request on a repo. And it works with any open source GitHub repo. You just give it organization name, repo, and pull request number, and then it summarizes you the entire pull request in the human language. And it also allows you to perform some tuning of the output. So for example, here in this release, several changes have been introduced to support data fixing and managing. And nodes has been added, which define classes and data structures for handling code diagnostics, blah, blah, blah. But then rewrite this like I'm 5 years old. And then, hey there, in this new update, the new open source library, we have made some changes to help, blah, blah, blah. So chat experiences are also possible with minimal code in Golang. Actually, in any languages, but this is just to prove a classical rewrite this is some 5-year-old interactivity. So yeah, it works. It works for half a year now, by the way. And so as a result, no LangChain, pure Databricks REST API, one binary as a result. And what does it mean for us? Like after 2 weeks of part-time effort in between other work meetings, I was able to reduce the release time from 1 hour for explaining releases and writing announcements to 7 minutes. And like before, I was just explaining and writing out release notes for everything and writing announcements, and then other people were hesitant to do it, and it was pain to 7 minutes because it takes 7 minutes to release. And most of the time it takes to release is coming down to removing LLM hallucinations and other minor edits, because LLMs still hallucinate even though you tell them not to hallucinate. It's still AI. It still hallucinates. So please open up your phones and take a look at and take a picture of this QR code so that you'll be able to try out this command line tool. It works. It's compiled for Linux, Windows, and Mac OS, and you can use it just 6 megabyte large. And you would be able to use it immediately after it if you have authenticated your machine with Databricks auth login through Databricks CLI and GH auth login to authenticate with GitHub API. So we kind of use it that way already. And it's available for you, and you can integrate it as a library. And do we have... Yeah, that's actually all of the documentation for it. Now, that's one use case. The other use case that we have with Golang, actually we have dozens of use cases for Golang, but I'm presenting you a couple of those, is like how to wipe thousands of test jobs users at scale. Because it's not trivial at all. And within Databricks Labs, we are doing heavy integration testing of our applications through GitHub OpenID Connect and GitHub Actions. And we create a few thousand test users daily. We create a few 100,000 jobs, a few 100,000 clusters, a few 100,000 high metastore tables just to test our Unity catalog migrations on the daily basis. And these fixtures are supposed to clean up after themselves, but sometimes they just don't because processes crash or application crash, and some test assets are just remaining sitting there in the workspace and increasing the time to run the full test suite. So you always know that when you're running scalable integration testing procedures, you are having two kinds of test datasets. You have static fixtures that are created by Terraform and take like half an hour to create, because it takes like half an hour to create a workspace and other remaining infrastructure. And those are always going to be managed by Terraform. And then you have dynamic fixtures that require cleanup. So you usually do a cleanup within the test framework, like Go test with T cleanup, or with PyTest with cleanup phase of the fixture. But if these things don't work, you have to do something more sophisticated to that. And for that purpose, I've written a system that's called Watchdog. So Databricks Labs Watchdog is like Chaos Monkey from the Simian army of Netflix that just goes to Databricks Workspace or Databricks account and nukes everything that's not managed by Terraform. You have to configure it to keep certain objects in the workspace or accounts and let it run. So we've been running Watchdog in our sandbox environments that we run tests on for 9 months so far, and it maintains them clean and secure. So because we have 5 levels of security protections in there, and this is just one of them. If there is a chance to persist a threat, it would not persist for longer than 1 hour. So how it works? It lists all workspaces, it lists 30 different object types, then it verifies the expected configs of those object types, and then waits for any CI jobs to finish, and does randomized parallel deletion of entities inside of accounts, like workspaces. And waiting for any CI jobs to finish is actually quite important, because you don't really want to nuke things when integration tests are running, otherwise you get flaky tests. Still, it happens, and it introduces some level of chaos to your integration test suite, making your application more stable as the result. It is very counterintuitive, but if your integration tests are sustaining the external influence that is malicious, then your code is, as a result, more robust and more secure. Because, for example, imagine your code expects that the entity, when you list something, it expects what you've listed would always be there the next second after you're making a call after list. But it's not the case in the real life. Life sucks because some things, some users or some automations can remove entities that you've just listed immediately after you listed them, and that make, and if code crashes, if your code crashes, then it's a bad code. So if your code assumes that entity is there after you listed it, it's a bad code, and you need to introduce some chaos testing. So how Watchdog operates? The first mode of operation is nuking, like Watchdog nuke enforce domains databricks.com. And for example, we have a couple of users, test user2 at example.com, and the message forbidden domain example.com. And we have like 5 users in example.com domain. Then we have a junk redash dashboard that we don't keep, and then we have a junk job run without an instance pool. And essentially, it's Watchdog with the default configuration is not keeping clusters without auto-termination or without instance pools or the clusters that are not pinned. And yeah, here is the input. Like in this default user interactive format, we give people an option to tell, hey, attention, this is destructive action. Proceed with care. Are you sure you want to destroy 9 objects? They cannot be recovered. Then you have to confirm this operation twice and then proceed. In the automation, what we run it in, usually as GitHub action or as Azure Container Registry task, we don't ask for confirmations because people should know what they are doing when they are scheduling it. And yeah, it works. So this is a command line interface documentation auto-generated by Cobra. So if you're using Go to write apps, Cobra is the way to write CLIs. This is what we use for our Databricks CLI, and these are almost all of the configuration options, either to connect to Databricks account or Workspace, or to provide configuration. And we have some custom automation to convert all of these flags into the YAML configuration files that are persisted in source control, so that things can work and things can be configured properly. That's basically it. I mean, what we write in Golang at Databricks, we write Terraform provider, obviously in Go. Our new command line interface is in Go because Python is the worst language ever. And we have SDK for Go with a couple of downstream projects like Watchdog and a couple of Ls. And to be honest, I would start any new applications that are given to the users in Go because dependency hell and dependency hell problem is non-existent, and when people are saying, yeah, but Go is very difficult to learn, well, anyone can learn Go in 3 days. That's what it was designed for. And yeah, and apparently it works quite easy with the Gen AI and data engineering, and it's easy to extend. So that's how we use Go at Databricks.